Hi, welcome back. Today's lesson is on keypad interfacing. A keypad is just a bunch of momentary contact switches. You know, you press the switch, it makes contact, you release it, it breaks contact. So the easy way to interface a keypad to a microcontroller is to use one input port bit per switch. So you have a switch on every input port, okay? And if you look over here, what happens is the switch is normally open. Okay, one side of the switch is connected to ground, the other side is connected through a pull-up resistor to an input port bit. Okay, so if that switch is open, I'm going to read a 1 on this pin right here, and if the switch is closed, then it's going to short this to ground and I'll read a 0 on this bit. Okay, so it's pretty simple, nice easy interface, but what if you have a lot of buttons? Well, you could use a lot of port bits, but remember a microcontroller doesn't have a whole lot of port bits and we're usually using them for other things. So if you think about a keyboard on your PC, your personal computer, it has over 100 buttons on it. Okay, you wouldn't want to use 100 port bits for that. So there's, that's a simple way to do it, is what you see right here, but simple is not necessarily elegant and not necessarily efficient. So remember, if this job were simple, anybody could do it, and if anybody can do it, you make minimum wage doing it. So deal with the complication, and that's where you get the good paying job. So, some brilliant engineer, who's not me, came up with the idea of arranging the switches in a row and column matrix. So if you look at the way these are arranged right here, we'll see that these switches, switches 1, 4, 7, and asterisk, those keys, are connected. They're all connected to column 0 on one side. Okay? And then keys 1, 2, and 3 are connected to row 0 on the other side. And we have pull-up resistors just so that if everything is unconnected, the bits are going to read a 1. Don't worry too much about those. Okay, so what we have is every time you press a button, what it's doing is it's making a connection. By the way, there's no connections between the rows and columns. These are not junctions right here. So the only time you'll get a connection between a row and a column is if you press a key. So if I press the 3 key, what I'm doing is I'm making a connection between column 2 and row 0. Now the problem is that doesn't really do me any good, because no matter what, I'm always going to read 1s the way this is configured right here. So let's take a look at this and say, let's say I ground all the columns. I put all 3 columns to 0 right here. So what's going to happen is if I have my rows connected to input bits on my port, I'm going to connect them to 4 bits on port D. If my rows are connected to input bits, if I press the 1 key down, what's going to happen is it's going to ground. Since column 0 is grounded, it's going to bring that ground over to row 0. So I'll know, hey, the 1 key was pressed because that was grounded. Now the problem is, I don't really know that it was the 1 key, because if the 2 key is pressed, it also makes a connection between ground and row 0. If the 3 key is pressed, it also makes a connection between ground and row 0. So this is kind of, phase 2, but it doesn't really work very well. So I have to find a way to control my columns a little bit. And I can do that by connecting the columns to output ports. So these are going to be 3 output pins, and I can control whether these are 1s or 0s. And remember, when you write a 1 to an output pin, it's effectively connecting the pin to VCC, and if you write a 0, it's effectively connecting the pin to ground. So if I write a 0 to this bit right here, that's basically connecting column 0 to ground, and now I can take a look at that. And what I'm going to do is I'm going to ground 1 column at a time. So if I write a 0 to this bit and write 1s to these 2, I know that only column 0 will be grounded. Now, if I find a 0 in one of these rows, I'll know exactly which key it was that caused the 0. I'll know which key is being pressed. So let's take a look at this. If I read my 4 port bits, my 4 input port bits right here, and I have column 0 being grounded, if I read a 0 on this bit, I know that the 1 key must have been pressed, because that's the only way that I would get a 0 here. It had to come this way. Okay? I know it wasn't the 4 key because this bit is a 1. I know it wasn't the 7 key because this bit is a 1. How do I know it wasn't the 2 key? Think about that. Pause the video if you need to and think about that. How do I know it wasn't the 2 key that was being pressed? Well, I know it wasn't the 2 key that was being pressed because if the 2 key was pressed instead of the 1, I would be connecting a 1. This column is a 1 right here, so I'd still be reading a 1 here. The fact that I read a 0, and this is the only column that's grounded, tells me that it had to be in this column, and the fact that it's a 0 here pinpoints it down to this key right here. Okay, and again, I know it wasn't the 4 key because this bit right here is a 1 and not a 0. So you try one. Looking at this configuration right here, I have written a 0 to this bit, I've written 1s to these 2 bits, and when I read these ports, these port bits right here, I read a 0 there and 3 1s there. So pause the video, think about that, and figure out which key is being pressed. Okay, I hope you came up with this. If you look at this, you'll see that since this is a 0 right here, we know that it had to be in this row. The key press had to be in this row because this is the only one that's a 0. These 3 are 1s. And we also know that since these 2 columns are 1s, it couldn't have come from those 2 keys. It had to be this one. So the pound key, the number sign key, was the one being pressed. Okay, do another one. Pause the video, look at this, think about it, figure out which key is being pressed right now. Okay, if you look at this, you'll see that I've now grounded column 1. So this is a 0. And I'm reading row 0, or excuse me, I'm reading row 2, then that shows a 0 on row 2. It shows 1s on the other 3 rows. So that tells me that this key right here, the 8 key, must have been the one that was pressed. So what you're going to do is really you're going to let the software put a 0 on one column at a time and then look at the rows. And anywhere you find a 0 on a row, you know which key was pressed because only one column is grounded. So what my software is going to do is it's going to continuously in a loop. And you might think, wow, if I can only do one row at a time, isn't that what if I miss a key press? Well, the fact is it's going to go through this. Remember I told you that a microcontroller is much, much faster than a human being. It will whip through this so many times. You can actually scan a keypad like this thousands and thousands of times, be faster than somebody can press a single key. Okay, talk about your keyboard on a personal computer. Okay, a lot of typists can type many, many words per minute. There's over 100 keys on this keyboard. It uses the same type of an algorithm for scanning the keyboard. It's got them arranged in a row column matrix, and you can't type fast enough to make it go too fast, to make it miss a key. So what the software is going to do is, let's start by, I'm going to write a 0 to column 0 and write a 1 to these 2 columns. Then I'm going to scan the rows. And anywhere I see a 0, if row 0 is a 0, I know this key was pressed. If row 1 is a 0, I know this key was pressed. If row 2 is a 0, I know this key was pressed. Okay, so I'm going to scan the rows one at a time by putting a 0 on this column, 1s on those 2 columns, and then I'm looking at just this column's worth of keys. Okay, then I'm going to stop that, and I'm going to put a 1 here, and a 0 there, and a 1 here. So I'll ground column 1, leave the other 2 columns high, and then I read my rows again. Okay, if row 0 is a 0, I know the 2 key was pressed. If row 1 is a 0, I know the 5 key was pressed, okay, etc., down to 8 and 0. Okay, then I'm going to put 1s on these 2 columns, put a 0 on this column. And I'm going to scan my rows again. Okay, if I get a 0 on row 0, I know the 3 key was pressed. If I get a 0 on row 2, I know the 9 key was pressed. Okay, so you just repeat that process over and over again, and it's not that hard to figure out which key is being pressed. You know which column you're grounding, and you know which row comes up low. Okay, now the complete solution. If you look at this right here, what happens is if I've written a 1 here, and it kind of depends on how the microcontroller is arranged, but in some microcontrollers a 1 is actually a dead short to VCC and a 0 is a dead short to ground. Well, the problem is if I press 2 keys in the same row, then what might happen is I might get a direct short from VCC to ground, and that's not good. That'll blow up your chip. Okay, that probably won't cause a puff of smoke to come out, but it will definitely damage the port bits, so that's not cool. So what we do is, over here we put diodes on here. So what happens is if I write a 1 is a direct short to VCC, that will actually reverse bias this diode. So this point right here would be floating, it wouldn't be connected to VCC, and we would get a safe 1 through this pull-up resistor. So it's not a dead short to VCC, it's a it's a pull-up going through a 10K resistor. Okay, so the diodes just make it a little bit cleaner, a little bit safer. So there's your lesson on keypad interfacing. I hope it pushed all the right buttons. See you in class.